Introduction. There are two major sections to this training program. The first section is an introduction to both channel bonding and partial service. The introduction section presents the concepts of the transmit channel set, multi-transmit channel mode, continuous concatenation and fragmentation, SIDs and SID clusters, and partial service detection, implementation, and recovery. You may use the links on this page to jump to either the upstream channel bonding overview or the partial service overview. Configuration and monitoring. The configuration and monitoring section provides examples of configuring the BSR for upstream channel bonding and configuring advanced spectrum management for the SNR threshold to be one of the means of declaring a channel in a bonding group to be impaired and so put into partial service. You may jump directly to the configuration and monitoring section of the program by using the links on this page. You may also view the program in a linear fashion using the navigation buttons at the bottom of the viewing window. Course objectives. Given a network design and system requirements, configure upstream channel bonding groups and enable upstream channel bonding. Using monitoring commands, verify the operational status of the cable modems. Determine if the DOCSIS 3.0 modems are in bonding mode, partial service, or in single channel operation, and correct any problems. Overview of upstream channel bonding. Upstream bandwidth. Upstream channel bonding allows a single cable modem to transmit data simultaneously on multiple upstream channels. Upstream channel bonding provides for increased upstream throughput of 100 megabits per second or greater for individual modems to allow cable operators to compete with fiber to the home and provide enhanced services to small businesses, as well as reducing the upstream limitations on downstream throughput for TCP data transfers. Additionally, upstream channel bonding will provide for real-time load balancing across bonded channels and more efficient utilization of upstream bandwidth. Upstream channel bonding design goals. Upstream channel bonding works on the same upstreams as the legacy modems, that is, the DOCSIS 2.0 and DOCSIS 1X cable modems. For example, there might be 6 upstream frequencies available to the cable modems connected to a particular fiber node. The modems may be a mix of DOCSIS 3.0 and 2.0 and 1X modems. Of course, the 2.0 and 1X modems can only tune to a single channel, but the DOCSIS 3.0 modems may tune to and transmit on up to 4 channels. The channels can be spaced anywhere in the upstream spectrum and can be any mix of modulation, channel width, etc. In other words, each channel is independent of the others at the physical layer. They are logically combined at the data link layer. Transmit channel set. The transmit channel set is assigned to the cable modem at registration time. The transmit channel set is determined by the BSR when the upstream port or ports are assigned to the fiber node and communicated to the cable modem in the registration response message. The BSR will assign the channels of the upstream bonding group to a DOCSIS 3.0 cable modem in multi-transmit channel mode as its transmit channel set. The transmit channel set of a legacy cable modem will be one channel. The transmit channel set of a DOCSIS 3.0 modem, not in multi-transmit channel mode, will be one channel. The transmit channel set of a DOCSIS 3.0 modem in multi-transmit channel mode will be the set of channels making up the modem's bonding group. Multiple transmit channel mode. A DOCSIS 3.0 cable modem using channel bonding is said to be in multiple transmit channel mode. MTC mode means more than just multiple transmitters. It means the modem is using continuous concatenation and fragmentation. It means the modem is using queue depth request. It means multiple outstanding requests are allowed for modems. It means these modems will be using SID clusters to identify their service flows. In short, MTC mode is designed for more efficient use of the upstream channels. Continuous concatenation fragmentation. The mechanism for DOCSIS 3.0 modems requesting more upstream bandwidth is to allow the cable modem to request for all the upstream bandwidth it currently needs based on the packets it has ready for upstream transmission, that is, frames in its queue. This scheme allows the modem to send up a request based on queue depth. Because the BSR does not know the individual packet boundaries and cannot grant fractions of the request without inadvertently crossing packet boundaries, this mechanism requires the continuous concatenation and fragmentation protocol, by which the upstream data transmission for a given service flow is treated as a stream of data regardless of the channel it is transmitted on and regardless of the packet boundaries. Legacy request grant mechanisms relied on the exact matching of request size and grant size. Once a modem made a bandwidth request, it had to wait until it received a grant allocating all of the bandwidth for that request before requesting additional bandwidth for that service flow. DOCSIS 3.0 modems operating in MTC mode are permitted to make additional bandwidth requests as upstream data for that service flow is enqueued, even before receiving grants allocating all of the bandwidth from the previous request. Elimination of the locked request grant bandwidth allocation mechanism will enhance upstream channel utilization per modem and also greatly reduce the data acknowledgement round-trip delay, limiting the throughput of higher layer protocols such as TCP. The BSR may issue grants in response to requests on some or all of the upstream channels associated with the service flow, regardless of the channel on which the request was received. Upstream channel bond segment. A segment is sent in response to a data grant received from the CMTS. A segment consists of a header to identify the portion of the stream of data being sent on a particular upstream and the data frame or frames. Each frame will include a DOCSIS header. A frame may actually be broken up and sent on two different upstreams. The segment header is used for all grants sent on the upstream of a channel-bonded modem. The pointer field points to the start of the DOCSIS header, if there is one in the segment. The sequence number is used to resequence the DOCSIS segments at the receiver. The SID cluster ID is included to allow the BSR to allocate bandwidth to specific upstream channels associated with the service flow. Two SID clusters are active at one time for an upstream bonded flow. When a modem transmits a bandwidth request, it must use the SID from the cluster of the channel on which the request is being transmitted. The request field is used to make requests for more grants. Including the request in the upstream data header is called piggybacking. SID clusters. In multiple transmit channel mode, every service flow, except for voice flows, must be assigned to an upstream bonding group. The upstream bonding group consists of one or more upstream channels over which a service flow can be transmitted. The BSR scheduler allocates bandwidth on the individual channels based on the available bandwidth on all of the upstream bonded channels. Requests transmitted on an individual channel may be allocated bandwidth on any combination of upstream channels within the bonding group associated with the requesting service flow. In this manner, the BSR can perform real-time load balancing of the upstream channels. All service flows have a service flow ID. Active and emitted upstream service flows are also assigned a 14-bit service identifier, or SID. A bonded modem has multiple SIDs associated with the bonded flow, and two SID clusters, which comprise a SID cluster group. The SID cluster is the means by which the BSR communicates to the modem, the upstream bonding group that the service flow is assigned to. SID clusters per service flow. The cable modem and BSR could get out of sync if a request or if a map is lost. The cable modem and BSR will recover from this temporary out of sync, but until the modem and the BSR recover, data delay and throughput will be impacted. To reduce the impact of the cable modem and BSR getting out of sync, DOCSIS 3.0 supports multiple SID clusters per service flow. The cable modem can make requests on one SID cluster while another SID cluster is recovering. The BSR uses 2 SID clusters per service flow. SID clusters per service flow. The reason for multiple SID clusters is that requests and grants are not tightly locked when MTC mode mechanisms are used, and therefore it is possible for the modem and BSR to become temporarily out of sync due to lost upstream request or downstream maps. This condition will eventually be resolved by the BSR, but can result in an additive delay buildup at the modem. In order to limit this delay and get the BSR and modem back in sync while the recovery process is ongoing, the cable modem switches SID clusters. In addition to the out-of-sync condition, the cable modem must switch SID clusters if any of the following service flow parameters is reached: maximum request per SID cluster, maximum outstanding bytes per SID cluster, maximum total bytes requested per SID cluster, maximum time in the SID cluster. Show SID cluster. To see the SID cluster information, you first need to select a modem and then get the upstream service flow ID for that modem. Using the service flow ID, you can enter the Show Cable SID Cluster command for that service flow and see the SIDs for each cluster. Notice that there are 2 clusters, 0 and 1, and the SID numbers are the same within the cluster. Granting bandwidth. DOCSIS map mechanisms are unchanged in DOCSIS 3.0. Each map message is associated with a single upstream channel. Maps do not need to be aligned across channels, nor do mini-slot sizes need to be the same across channels. DOCSIS 1X, 2.0, and 3.0 cable modems are all supported using the same map. The BSR has complete control in granting bandwidth to the cable modem. The cable modem sends the request for the bandwidth needed for a given service flow on any upstream channel available to the service flow. The BSR can choose to grant the bandwidth on the upstream channel upon which it received the request, or on any other upstream channel associated with the service flow, or on any combination of channels associated with the service flow. Service flow assignment. All static and dynamic service flows except UGS and UGS-AD service flows for DOCSIS 3.0 cable modems in MTC mode are bonded. UGS and UGS-AD service flows are not assigned to a bonding group. A UGS or UGS-AD service flow is assigned to the channel within its cable modem's transmit channel set that has the most available bandwidth for the service class to which the service flow belongs. Polls for real-time polling and non-real-time polling service flows are scheduled on a single upstream channel as well. Upstream bonded service flows in the same service class and bonding group receive bandwidth proportional to their assigned minimum reserved rate. MAC domain descriptor message. The MAC domain descriptor message is read only by DOCSIS 3.0 modems. This important DOCSIS control message is used by the DOCSIS 3.0 modems for many things, as listed below. For upstream channel bonding, the MDD lists the upstream channels within the MAC domain that the BSR may have the modem check by ranging to determine exactly its upstream service group. It will tell the cable modem the upstream spectrum range, extended or standard, and it may be used to tell the cable modem to report its transmit power levels. Upstream cable modem service group resolution. After resolving the downstream service group, the BSR attempts to determine the modem's upstream service group. The modem creates a list of candidate upstream channel IDs from the Upstream Ambiguity Resolution channel list contained in the MDD message. The modem then collects upstream channel descriptors, messages, received on its downstream channel, saving those UCDs for upstream channels with the upstream channel IDs contained in its upstream channel candidate list. The modem will then be told by the BSR to range on the different channels, one at a time, so that the BSR can determine which service group the modem belongs to, that is, which upstream channels it can use to reach the BSR. The service group determination is likely to be trivial, in which case this step would be omitted. The next slide provides more details on this process. Initial ranging response. The BSR, upon receiving a BINIT ranging message, uses the MAC domain downstream service group ID and the upstream channel on which the ranging request was received to determine if a unique upstream service group can be determined. If a unique MAC domain upstream service group cannot be determined, the BSR sends a ranging response to the cable modem, including in the message an upstream channel adjustment TLV containing an upstream channel ID, temporary SID, and initialization technique for a second upstream channel. The cable modem, upon receiving the ranging response message containing an upstream channel adjustment TLV, then waits for a ranging opportunity for the new upstream channel. In this way, the cable modem and BSR are able to determine unambiguously the upstream channels that the cable modem can use to transmit to the BSR, in other words, the MAC domain upstream service group. Dynamic range window. For modems operating in MTC mode, DOCSIS 3.0 requires that the transmit power levels used by the modem for each of the channels in its transmit channel set be within a 12 dB range, referred to as the dynamic range window. The BSR and cable modem exchange information about the cable modem's transmit power and required dynamic range window to maintain the transmit power of all the channels in the bonding group within this 12 dB wide window. In the MDD, the BSR tells the cable modem to send the transmit power level on each of its upstreams to the BSR in the cable modem's ranging request message. The BSR calculates the ranging window and communicates the upper boundary to the cable modem in the ranging response message. The BSR uses the modem's channels modulation, channel width, and other parameters in a formula to determine the dynamic range window. Bonded cable modem registration. To register, the DOCSIS 3.0 cable modem sends a registration request with the received channel profile that describes the modem type, for example, a 4-channel capable downstream and upstream bonded modem, to the BSR after performing initial ranging, DHCP, and TFTP. The BSR responds with the received channel configuration, which tells the modem to tune its receivers to certain frequencies for downstream channel bonding. In addition, the BSR sends in the registration response message the transmit channel configuration, which adds, deletes, or changes upstreams in the transmit channel set. Thus, it is telling the modem which upstreams to use for upstream channel bonding. The modem achieves sync lock on its downstream channels and performs ranging on its upstream channels. Remember, prior to this, the modem only did initial ranging on its primary channel. If all downstream and upstream channels are acquired, the modem sends a registration ACK message to the BSR. Otherwise, in the registration ACK message, the modem sends error messages indicating the problem. Bonded cable modem registration. At this point, the BSR begins sending bonded traffic on bonded downstreams and receive bonded traffic on the bonded upstreams. The upstream service flow traffic is now spread across multiple upstream channels, and the modem uses segment headers for each grant on the upstream. A grant is given, and the modem sends a segment on a bonded upstream. Sequence numbers are embedded in the header to assist the BSR in reordering of the bonded traffic. Upstream partial service. Upstream partial service. When one or more of the upstream channels in the cable modem's transmit channel set is not available or has degraded, the BSR puts the modem into partial service condition. Partial service can apply to a single modem, to multiple modems, or to all modems on an upstream channel. A single DOCSIS 3.0 modem would be put into partial service if 1. The BSR receives a cable modem status message indicating an unusable upstream channel, 2. The modem sends a NAC in its registration response or its dynamic bonding change message indicating an unusable upstream channel, 3. The BSR does not receive ranging request in response to station maintenances sent to the modem. All DOCSIS 3.0 modems in MTC mode on a particular upstream channel would be placed into partial service if advanced spectrum management were being used and SNR for the upstream channel degraded below the threshold value for the channel. Implementing partial service. Once a channel has been placed into partial service by the BSR will stop sending grants to the modem for that upstream channel, but will continue to send station maintenance opportunities to the cable modem for the affected upstream. Voice flows on the bonded cable modem will be moved to another upstream to avoid the problem. Recovery. When advanced spectrum management detects that the SNR has recovered, that is, the threshold value for that upstream is met or exceeded, the BSR begins scheduling grants on that upstream. Or, if the BSR receives a cable modem status message indicating that the partial service condition no longer exists, the BSR begins scheduling grants on that upstream. Or if the BSR begins to receive ranging messages on the affected upstream, the BSR begins scheduling grants on that upstream. Configuration and monitoring of upstream channel bonding. Multiple transmit channel. By default, each BSR MAC domain is configured to accept a DOCSIS 3.0 modem with the bonding bit set to enable multiple transmit channel mode. In order for that modem to use upstream channel bonding, the operator would have to create a cable modem configuration file with the upstream required attribute mask, with the most significant bit set to 1. Any modem that did not have that bit set to 1 would not be able to register as bonded. In other words, upstream channel bonding is enabled via the cable modem configuration file. Service flow attribute mask. Both the service flow attributes required and forbidden are configured in the cable modem configuration file, but are optional. If the service flow attributes are not present in the configuration file, then the CMTS assigns the service flow as it sees fit. There is an attribute mask for the upstream flow and another attribute mask for the downstream flow. These attributes are defined by a 32-bit field. Each bit represents an attribute and can be set to either 1 or 0. The first 16 bits are reserved by DOCSIS, with the first 3 bits, starting with the most significant bit, defined as bit 0. Bit 0 is the bonded attribute. Bit 1 is high availability, and bit 2 is low latency. The other 13 bits are not defined by DOCSIS, and bits 16 through 31 are user-specific. Multiple transmit channel. Multiple transmit channel mode can be enabled for all modems in the MAC domain, regardless of the setting of the bonded bit in the service flow attribute mask in the cable modem configuration file by entering the cable MTC mode command in the cable interface on the BSR. However, if the forbidden mask in the cable modem configuration file has the bonded bit set to 1, then MTC mode will be disabled for that modem. The easiest way to enable upstream channel bonding for all DOCSIS 3.0 cable modems in the MAC domain is to use the cable MTC mode command on the BSR and leave the service flow attribute mask out of the modem configuration file. Multiple transmit channel. To disable upstream channel bonding for all modems, regardless of the service attribute mask setting, use the No Cable MTC mode command. Note that this does not restore the default. Instead, it disables MTC mode across the MAC domain. To restore the default settings for MTC mode, enter cable MTC mode required attribute. Ranging. In order to reduce the overhead incurred by ranging on multiple upstreams, the BSR will poll the modem at a frequency equal to the T4 timer multiplied by 4 for a 4-channel bonded upstream. The multiplier can be changed by using the cable T4 multiplier command. From a practical point of view, this parameter lengthens the time it takes before the BSR realizes that a cable modem is not responding to station maintenances. Configuring upstream channel bonding. To configure upstream channel bonding, the operator from the interface cable command creates the MAC domain by binding the downstreams and upstreams that make up the MAC domain using the cable bind downstream and the cable bind upstream commands. Once the MAC domain is created, the operator may configure the upstream bonding groups. Upstream channel bonding configuration. In this example, we are creating two upstream bonding groups, 5040 and 5041. The upstream bonding group number is arbitrary. I chose 50 because the MAC domain is 5/0, and 4 because it is a 4-channel bonding group, and 0 for the first 4-channel bonding group, and 1 for the second 4-channel bonding group. I could have just as easily chosen bonding group numbers 1 and 2. The range for the bonding group number is 1 to 65,536. I add the upstream channels to the bonding group using the port/channel/logical channel syntax separated by a space. Finally, I set the MTC mode to enable by entering cable MTC mode. This will force all DOCSIS 3.0 cable modems on the 5/0 MAC domain to use MTC mode, that is, upstream channel bonding. Remember, the default for the MTC mode is to use the upstream attribute mask to determine which modems on the MAC domain are bonded. I enter the show cable upstream bonding group command to verify my configuration. Show cable modem. I then enter the show cable modem command to see that the DOCSIS 3.0 modems registered as bonded. The way I can tell is by viewing the third column from the left, primary upstream. For bonded cable modems, this will display B for bonded, followed by the bonding group number. Configuring upstream channel bonding. Let's analyze this configuration a little more. Notice that the modems connected to fiber node A and the modems connected to fiber node B all share the same upstream port on the RX48 card, hence the same upstream channels. Therefore, both sets of modems can use any of the 6 channels to range and begin registration. For that reason, I had to create 2 4-channel bonding groups. Configuring upstream channel bonding. Let's take a closer look. If I had created only one bonding group, say 5040, then modems registering on upstream channels 4 and 5 would not be a member of the bonding group and would register like a DOCSIS 2.0 modem, that is, it would have only a single upstream channel. In order to avoid that possibility, I created 2 overlapping bonding groups so that all channels would be part of a bonding group, and therefore any DOCSIS 3.0 modem would be part of a bonding group. Show commands. The Show Cable Upstream Bonding Groups command gives a nice snapshot of the bonding groups and the important parameters that make up the bonding group: channel frequency, channel state, channels, channel IDs, and group IDs, all by MAC domain. Show commands. The Show Cable Upstream Bonding Groups Statistics command shows how data traffic is distributed across multiple upstream channels. Show commands. The Show Cable Modem Upstream Bonding command shows only DOCSIS 3.0 registered modems that are in channel bonding mode. If a multi-channel modem registers with MTC disabled, it will not appear in this list. Use the Show Cable Modem Upstream Non-Bonding command to see the DOCSIS 3.0 modems that are not in bonding mode. If the active transmit channel set ID is different from the assigned transmit channel set ID, the modem is in partial service. Show commands. The Show Cable Modem Upstream Partial Service command shows only DOCSIS 3.0 registered modems that are in channel bonding mode but are in partial service. Configuration and monitoring of partial service triggers for upstream channel bonding. Advanced spectrum management. Advanced spectrum management can be used to detect an impaired channel and trigger the DOCSIS 3.0 bonded modems on that channel to go into partial service. If advanced spectrum management is not configured, create a spectrum group, assign the upstreams to it, and then enter the command Cable Spectrum Manager Partial Service Enable. No hop action rules are needed. Advanced spectrum management will monitor the SNR on the upstream channels. If a channel degrades, that is, the channel SNR drops below the threshold, advanced spectrum management will trigger partial service for the DOCSIS 3.0 modems.
ASPM and partial service. In this demonstration, I am creating a spectrum group called SG1. I then assign that spectrum group the upstreams. In this case, I assign it to upstream 5/0/2. Notice that in the Show Cable Spectrum Group command, you can see that partial service is disabled because I have not enabled it in the cable interface. I have only created the spectrum group. I then go to the cable interface and enter the Cable Spectrum Manager Partial Service Enable command. Notice that in the Show Cable Spectrum Group command, you can see that partial service is enabled because it shows the member channels and that they are enabled for partial service. In this demo, you can see that 5/0/2 is enabled for triggering partial service when the SNR threshold drops below 28 dB minus the hysteresis 2 dB because ASPM is listed as enabled.
Advanced spectrum management. If advanced spectrum management is already configured with no hop action rules, ASPM attempts to avoid the impairments by changing channels or changing modulation depending on how it is configured. When noise or distortion occurs, if the hop action does not work, that is, if the channel is still impaired, then ASPM will trigger partial service for the DOCSIS 3.0 modems. An enhancement to advanced spectrum management has been added that allows the operator to configure a threshold for DOCSIS 3.0 modems. If ASPM is configured with modulation agility, the operator can specify the level at which the DOCSIS 3.0 modem will be put into partial service. This feature allows a degraded upstream channel whose bandwidth is shrinking each time the channel drops down in modulation to give the remaining bandwidth to the DOCSIS 2.0 and 1X modems by putting the channel into partial service for the DOCSIS 3.0 modems. See the next slide for an example. Modulation mode partial service trigger. In this example, advanced spectrum management is configured in the BSR for modulation agility. In this case, the modem's regular upstream modulation is 64 QAM. There are rules configured in ASPM for the modulation to change to 32 QAM and to 16 QAM if the SNR drops below the threshold values. There are 4 upstream channels, and the DOCSIS 3.0 modem is using all 4 channels because it is doing upstream channel bonding. Focusing on channel 0 for a moment, notice that there are legacy modems as well as DOCSIS 3.0 modems on channel 0. When noise or distortion occurs on upstream 0, such that the SNR drops below the threshold for 64 QAM, ASPM will command the modems on that channel to change modulation. This may help the modem to operate in the presence of noise, but the trade-off is reduced throughput. Suppose the noise and distortion causes the modems to drop below 32 QAM to 16 QAM. The modulation mode partial service trigger command causes the DOCSIS 3.0 modems to go into partial service, and the legacy modems have less competition for the limited bandwidth on the degraded channel. Advanced spectrum management trigger and partial service. In this demonstration, I configure advanced spectrum management for modulation agility by creating 2 hop action rules for 16 QAM and 32 QAM. I then add the modulation mode partial service trigger and set it to 16 QAM. This means that if the channel SNR degrades to cause 16 QAM to be the channel modulation, then ASPM will put the channel into partial service. All the DOCSIS 3.0 modems in bonding mode will be unable to use that channel, but the DOCSIS 2.0 and DOCSIS 1X modems will still be able to use it. When I do the Show Cable Spectrum Group command, I can see that the channel has indeed dropped down to 16 QAM because of noise, and that the partial service is enabled for channel 5/0/2.
Summary. We have seen that with the DOCSIS 3.0 upstream channel bonding feature, cable operators are able to offer high-speed data, voice, and video services by increasing the upstream bandwidth. Using DOCSIS 3.0 cable modems that support multiple upstream channels bonded together at the data link layer, channel bandwidth can be increased to more than 100 megabits per second. The data stream for DOCSIS 3.0 modem in multi-transmit channel mode is treated differently than that of legacy modems. With bonded modems, data is a continuous stream of packets grouped into segments. A segment fulfills a grant. The stream of data grouped as segments is sent on multiple upstreams at the same time. This group is called a cluster and represents the bonded flow. The configuration of upstream channel bonding is simple and flexible. Channels are assigned to a bonding group, and the operator gives the bonding group an ID. A single channel may be a member of more than one bonding group. The modems learn of their bonding group assignment when they register. Since the concept of a primary upstream no longer applies to a modem in MTC mode, the Show Cable Modem command will display the bonding group ID in the primary upstream channel column. If the channel quality of an upstream channel of a bonding group becomes impaired, the BSR will put those modems using that bonding group into partial service.
the modems will still be transmitting on the other channels. If the channel quality improves, the BSR will put those modems back into service. Advanced spectrum management can be configured to identify an impaired channel and trigger partial service. This concludes the Upstream Channel Bonding Self-Study course. If you have any comments, suggestions, or corrections, please send them to broadbandtrainingsolutions@motorola.com. Thank you.